Alright, so today we are talking about solving linear inequalities. Just a reminder, an inequality is anything that is less than or greater than. The prefix "in" means not, so not equal for inequality means one would be greater than or less than. So, we started off by looking at just some basic inequalities, and we said that 8 is greater than 5. And then we said, well, if I kept the 8 and I kept the 5 and I multiplied both sides by 2, 2 times 8 is 16, 5 times 2 is 10, so 16 is greater than 10. We noticed that multiplying a 2 on each side didn't change that sign. So we tried a 3. 3 times 8 is 24, 5 times 3 is 15, so once again 24 is greater than 15. So by the rules of inequalities, as long as I do something to one side, as long as I do it to the other, it remains the same. However, if I multiply by a negative number, negative 2 times 8 is negative 16, and 5 times negative 2 is negative 10, and since we're now talking about negative numbers, that's the opposite, so negative 16 is actually less than negative 10. Same concept down here. Negative 3 times 8 was negative 24, and 5 times negative 3 is negative 15. Well, since they're negative numbers, negative 15 is greater than negative 24, so our sign would go this way. We determined that the rule for inequalities is as long as you do something on one side, you can do it to the other, same rule as equations. But the only kickback was when we multiplied or divide by a negative number, then we have to remember to change the direction of our inequality sign. So, let's take a look. Before we get started, we wanted to talk about what an inequality is. Inequality means not equal, so we use the symbol less than, greater than, less than or equal to, greater than or equal to. All of those symbols mean that we have an inequality. These two down here on the bottom could be, right here, could be equal to as well, but it's still an inequality symbol. When we put it on a number line, it is important to remember that the greater than and less than symbol is an open circle, which means all the points up to that exact point are included, but the point itself is not. And then if it's greater than, equal to, or less than equal to, then it is a closed circle, implying that that point is included also. When the variable is listed first, the graph shades in the direction of the arrow. For instance, as long as the variable is first, if it was x is greater than 4, when you shade, this symbol right here creates an arrow for your shading. So let's take a look at that. One other thing to keep in mind is if you multiply or divide by a negative number, you must change the direction of that sign. Very important. So, I have a problem here. 2x plus 4 is greater than 24. 2x plus 4 is greater than or equal to 24. We're going to treat this just like we did the equations. We're going to draw a line through our inequality sign. I want to get this x all by itself, so I have to get rid of the 2 and the plus 4. Since that 2 is attached to the x, we're going to peel it back in layers by subtracting a 4 from both sides first. 2x I didn't do anything with, so it comes down. 4 minus 4 goes away. Bring down my inequality sign. 24 minus 4 is 20. Divide both sides by 2. And I get x is less than or equal to 10. Since it's, x is greater than or equal to 10. Since it's equal to, I'm going to come to 10 and draw a closed circle. We want numbers that are greater than 10, so 11 is greater than 10, 12 is greater than 10, 13 is greater than 10. So that means we're shading in this direction. And if you remember, this arrow, this symbol points in the direction that our shading happens. If you were to type this into your calculator by using graph delete 6, type it in exactly how it looks, you would get your coordinate plane. Here at 10, you would have a straight line, and this direction would be shaded. Since the shading is going in that direction, you can always take away that middle part of your arrow, and that becomes your symbol. And since it's underlined in your problem, it's going to be underlined in your answer. Since this happened at 10, we would say x is greater than or equal to 10. So that's another way you can solve it inside of your calculator. Okay. Next problem, we have 3 parentheses p plus 1 is less than or equal to negative 18. Negative 3 parentheses p plus 1 is less than or equal to negative 18. The first thing I want to do is distribute to get rid of these parentheses. So my problem becomes negative 3p, negative 3 times 1 is a negative 3, less than or equal to negative 18. I want to get this p all by itself. So I have a negative 3 that's attached, and then the minus 3 that's just hanging out over here. We always peel it back in layers, so I'm going to get rid of this 3 first. If I do it to one side, I've got to do it to the other. That leaves me with negative 3p is less than or equal to negative 18 plus 3 becomes a negative 15. If I divide both of those sides by negative 3, when I divide by a negative, I have to change the direction of this sign. So now my answer becomes p, and instead of less than, it is greater than or equal to. A negative divided by a negative is a positive. So I have p is greater than or equal to 5. So I come in right here. Since it's equal to, it's going to be a solid number. I want the numbers that are greater than it, so we're talking about in this direction. So I can shade clearly. Notice that this symbol and the direction of my shading are different. This symbol does not mean that my entire shading goes that way. It all depends on what happens after the math. Since I divided by a negative number, I had to change the directions of the sign. If I were to type this into my calculator just like this, go into graph, delete 6, put it in exactly how it looks, minus 3, remember inside of our graphing we always use that minus sign so the negative sign doesn't trip us up, minus 3 parentheses x plus 1 close parentheses is less than or equal to minus 18. We would get a solid straight up and down line here at 5, and our shading would be going in this direction. So we wouldn't have to remember the rule of changing the direction of the sign because our calculator does it for us. Since my shading starts here and goes in that direction, if I took the middle of that symbol out, that would become my new sign. Since it's underlined in my problem, it's underlined in my answer. X and 5, or actually for this problem it would be p, is greater than or equal to 5. Once again, you can always check them in your calculator. Make sure you change your variable to an x because your calculator lives in XY mode. Use control equal to get those inequality signs, and double check and make sure that you have the correct symbol typed in because that is a big part of this problem. Just a reminder, we graph and delete 6 to get into relation mode. Enter the equation how it looks and use menu 5-1 to trace. Solution symbols should be pointing in the direction of your shaded area. Your calculator will take care of all of that work for you. All right, have a great day.